Thank you very, very much, and good afternoon, it is, everybody. Just very nice to not see you in a sense, but I rather hope you can see and hear us. So today's webinar is entitled Challenges on the Horizon, a look at the future of airspace. For those who don't know me, I'm Pete Round. I am the President of the Royal Aeronautical Society for this year and into a proportion of next. And it's my absolute pleasure to be chairing our meeting and webinar today. The speakers are Tasos Pantelis, who's part of Protolabs, Dr. Helen Lockett, who is a senior lecturer at the Open University, and Colin Sirett, who is the director of CBS Partnerships Limited. And they are going to look after us first. So, still a few people joining, but I think, as Emma said a second ago, we are slowing down and most people are on board. A couple of practical matters that I'll just run through. We're going to have an introduction in a minute from Tasos, but there will be an opportunity to pose questions, and I really ask you to do so. I don't want us just to lead this. So put your questions in via the chat function on your control panel during the presentations, and we'll pick up as many of those as we can as we go through. When you put your question in, we know who you are, of course, but it'd be great if you put your company name in as well, please. You're all in a listen-only mode, so if you need to contact us for any reason, technical issue or anything, do use the chat function and someone will come back to you and help you out. So as I said, we'll have a short introduction from Tasos and then a panel discussion, and I'll do a little more on each of the panel members when we get to that. And then there's a Q&A session as well with the finishing time, as you know, of 1 o'clock. So Tasos Pantelis, who is full title, his job is European Project Engineer, Additive Manufacturing at Protolabs. He's qualified in Design and Mechanical Engineering, and for the last 6 years he's been part of the team at Protolabs. He started as an applications engineer, a team key to the internal and external stakeholders, offering high-level technical support and advisory to clients searching for design and manufacture solutions. He became the Protolabs Additive Manufacturing Champion during this period, and he's the go-to representative for this sort of process and capability advice. This year, he joined the Centre of Excellence for Protolabs in Putzbrunn as the European Project Engineer, with a focus on evolving Protolabs additive manufacturing capability and support for clients. And Tasos continues to develop his knowledge and understanding. You'll often see him in trade articles, presentations, papers, and industry-specific panel discussions. A great portfolio and a strong position as an influencer in the additive manufacturing arena. So, Tasos, without further ado, over to you.
Thank you, Peter, and my turn to welcome everyone to today's webinar. So I will share my screen shortly just to have a look at some interesting figures. So first of all, please allow me just a few moments to highlight some key facts and figures for the company I work for Protolabs. So first of all, the company was founded in 1999, and the vision was just to have very fast and on-demand manufacturing along the industry, and this was shared with our many customers. And success and partnership has enabled us to actually speed up manufacturing in a variety of industries. So what makes Protolabs different? So that's a very key area here, is that the main thing is that our unique digitally lit manufacturing processes make sure that we can make parts, we can build parts faster and with the least possible risk than others within manufacturing. So what I mean by saying fast is that we can produce parts on one business day, for example, for injection molding, one business day for CNC machining parts, as well as one business day for 3D printing parts. So how do all these link to aerospace? So first of all, the advancements in rapid prototyping and on-demand production capabilities has revolutionized the mindset of product developers. So the very important thing is that the development cycle is much smoother due to the necessary parts being delivered faster and, of course, much more cost-effective, in a much cost-effective way. So the ability to physically hold production quality parts significantly faster than previously has proven to be a very key point for certification as well as test processes. So Protolabs on-demand production capabilities, coupled with the broad range of manufacturing methods, and provides the right level of flexibility, speed, and scale to save customers both time and money. So now we can have a quick look on the actual industry report, what we found out in the last few years. So the aerospace industry is no stranger to innovation, but we have already had some challenges of the pandemic, and of course the ongoing needs to address carbon emissions, and this left some difficult challenges on the horizon. So these key areas were recognized by the Protolabs research project, which was conducted 2 years ago, which is called the Horizons Shift. But we can highlight and we can review today how the industry is shaping up now. So the disruption is well known to accelerate innovation and COVID-19. So we can see some nice figures here about the feedback we received. So, for example, the 58% of the people who were asked believe that the autonomous aircraft and on-demand flights are the future of commercial aerospace. And although we know that during the pandemic, passenger numbers flattened, while demand for global air cargo, particularly medical supplies, actually took off. So another key point here is that the new materials, the evolution of the materials and the material science is a great need in order to create an opportunity to reduce the overall environmental impact. And of course, it has been highlighted that in the next couple of years, there is an expectation on the use of advanced manufacturing techniques in order to improve and enhance productivity, and to create a bigger range, a more flexible product range, and to deliver parts in a greater speed, and of course, make sure that this assists on further innovation of things. So this is pretty much just a quick screenshot of what we will discuss today, and the points that we will be able to comment and have a more comprehensive understanding and feedback. So down to you, Peter.
Forgive me. Great, Tasos. Thank you very much for that introduction. I'm now going to, before we go to questions, bring our other panelists in, and I'll introduce them both first and then let them speak. So first, Helen Lockett, who's the Senior Lecturer in Engineering and Director of the Open STEM Lab at the Open University. She's a Chartered Engineer and member of the MRAeS and a STEM ambassador who's worked with local schools and businesses to encourage young people to consider careers in engineering. She's shared her expertise in TEDx talk and been interviewed on the BBC World News, with more than 20 years research experience in design for manufacture, being CAD, CAM and CAE. She's got particular interest in designing for additive manufacturing and has worked closely with the aerospace industry on design for additive manufacture of high-value aircraft parts using direct energy deposition. She's also participated in Innovate UK, EPSRC and EU framework projects, as well as industry-funded projects with a variety of aerospace companies. She's contributed to the writing of ASTM and ISO design guidelines for additive manufacturing. Colin Sirett, a fellow of the Society and director of CVS Partners, which is a consultancy company specializing in providing services for strategy, business development, inward investment, program management, technical portfolio development and change management. He's also a non-executive director of MSc Consulting Services. Previously, he was chief executive of the Advanced Manufacturing Research Centre in Sheffield and director of Casting Technology International. He joined AMRC from Airbus in 2016, where he was in the Research and Technology National Representative for Airbus in the UK. Prior to this, head of landing gear on the A350 XWB programme. Before that, coming from the automotive industry. I think that probably covers most of it, Colin, for you. So we've got some very eminent people to help us with this. First, I'm going to pass to Helen.
Well, thanks for that long introduction, Peter. It's very kind words. I don't have very much to add, as you say. You said most of the things I'd wanted to say. Perhaps just to add, I'm also a member of the Structures and Materials Committee for the Aero Society, and I'm particularly interested in sustainability aspects of future aircraft developments. What can we do as an industry to reduce weight in our aircraft and look at the whole life cycle aspects of our future aircraft designs? So with that, I'll hand over to Colin.
You're muted, Colin.
That's better. Thank you, Helen. And really, the first question, which is what are the main challenges for the aerospace sector? To say that there's a conference level question poised at the start would be an understatement. But I think it's fair to reflect that the whole industry and other industries have faced unprecedented times. It has been a case of adapt or die. So yes, we are having disruptions at airports, flights not in the right place, it's taking longer to get passports, but this is all of a consequence of an industry coming out of a global pandemic and the restrictions that's caused. On the plus side is we have still got an industry, and it's that sustainability aspect that is critical in when we look at the challenges for the aerospace sector in particular. And that's not just not just environmental, they are also economic and social as well. All of this is going to be conducted on a backdrop of a 40% reduction in global resources in the sector. So if you look at that in context, we've all experienced quite an outflow of capability that's moved out of the very critical positions within our industry, and something that needs to be grown back at the same time as we're progressing the new technologies. And that's why I say sustainability is not just environmental, it's economic and social. So if we look at the four challenges, and they've never changed, and nor I don't think they will change. The four main challenges are to have, for us as a sector industry, to have a product that is as lightweight as possible. It has to have the most efficient propulsion system, the best aerodynamics, and be operated in the most efficient sort of manner to reduce, wherever possible, its impact on the global environment. And at that point, what I would do is I would strongly commend the latest publication of the Aerospace magazine. Two articles in particular. There's one by the numbers, which just shows you where those sectoral changes have hit, or reductions in resources have hit, but also the article, the feature penned by Ian Pohl, Aiming Higher, because there's a balance of activities that we need to conduct over the coming months and years, and all aspects have to be addressed. We're not going to come through this successfully if we just focus on one. So where to start? Main challenges for aerospace: double-digit returns for the airlines. Unless the airlines are making money, they're not going to be buying planes, and it feeds down all the way through the supply. When the article was, or when the publication came out from Protolabs and the report, it didn't envisage the crisis we currently have in the Ukraine. This brings into sharp relief another dimension, which is the cost of raw materials and also the security of supply, all of which feed into looking at more additive approaches when we're looking to structural components. So there's many areas I could delve down into in this, but I'm sure they will come out during the discussions. So if I could pass over to Tasos.
Colin, thanks very much for that. I think the next question, if I can dive straight to it, and then I'll pass straight across to Tasos, is have these challenges changed since the pandemic? And do you think that the pandemic has driven a change in mindset, which gives us opportunities? Perhaps Tasos, you want to go at that first?
Thank you, Peter. So I would comment firstly on the very valid and really good points Colin said just a while ago. So as a very short answer, I would say that these challenges have grown. So they're still there, but with these challenges that we live lately, and especially the result of the war with regards to the supply of the raw materials and generally the security, as Colin mentioned, I believe we need to give an extra attention to these points. Of course, some of them would be unavoidable in the short term, but while working well on the and focusing on these points with regards to the carbon footprint, the lightweight, and just keep evolving further, and mainly on the material sector, I would say that another key point here would be to design smarter, and especially by using the additive processes, especially 3D printing, where we have now a bigger variety of a bigger experience, a bigger variety of material options, different approaches, which could lead to really much more cost efficient and lightweight parts. So this could be a nice and a good point to work around these challenges, and could be used as a tool in order to speed up the results that we try to achieve, but at the same time to make sure that the new engineers coming will be trained accordingly in order to get the best possible outcome. So all these challenges, I believe they still exist. We still work on this, and the industry has been mature enough to understand what is coming, but we all need to work like a chain in order to further evolve and improve all these challenging tasks we have.
Thanks, Tasos. Colin, I don't know if you want to add to this, and perhaps segue then into what the future R&D plans are as you see it.
Yes, with the support we've had from government to the various airlines and businesses, that has come with a pretty fundamental condition, which is the investment must be repaid back by taking a more aggressive stance when it comes to the environmental footprints that we produce, and that at first sight, as I said earlier, looks to be just purely environmental speak, but it's not. There's a very strong symbiotic relationship between the airline operators, and the environment. If we consume less fuel, we produce less emissions. If we consume less fuel, we actually make it more cost effective to operate the fleet. So the two things actually go hand in glove. They are really focused on the same outcomes. Taking that a step further into what are the sector's plans for future research and development, we are very fortunate that we've got two enduring programs that have assisted us greatly since 2010, that being the Aerospace Technology Institute and then the High Value Manufacturing Catapult. Both of these, I'd refer to them as lighthouse programs, excuse me, because they represent an investment from the government of about 2.4 billion over that time period. And the government is looking to continue the same level of support going forward. Now, in its own right, that's a big figure. What's comforting is the return on that from industry is that industry has more than matched that figure. So we've got a very strong platform for the research programs going forward. The areas to consider, though, is the impact, again, it's the impact of the reduced workforce and what that is now going to drive as a way of working for more collaborative programs, consortium research, and actually making sure that we've got the whole product life cycle covered in those programs. Because we will be monitored very closely of what immediate effects we're having. And after that, you're then looking at how can we make it lighter? How can we make it more efficient on fuel? What are the best aerodynamic shapes that we can produce? And what is the best way that we can operate these aircraft going forward?
Great. Colin, thank you very much. Just before we move on, if I can encourage questions, we're a tad thin in the chat on those at the moment. So please, if you have any questions, don't be shy. We've got one. I'm not sure if this is Tasos or which is the question from is what is the current UK position in the Horizon projects post Brexit? If one of you has an expert view on that.
I don't have an expert view. I have having read in the news view that I understood they were aiming to keep us in Horizon in the short term, but there's been news articles saying that PIs have had their projects removed. So I don't know any more than I don't have an expert view.
No, that's my understanding as well. So we'll leave that and perhaps have to come back with a definitive view. But I think that's right. So as I say, please do ask any questions. So moving on, perhaps Helen, you might talk to us about how you think the sector's adoption in digital manufacturing and the wide spectrum of technologies now on offer is, how's that affecting engineers and program designers? What's changing there?
Well, I think end-to-end digital design and manufacturing processes, the aerospace industry has already come a very long way doing that, and that's brought in some opportunities to do some of the things Colin's talked about. So better design optimization leading to lighter weight structures, allowing us to bringing new technologies. I think the area I'm particularly keen to talk about is additive manufacturing, because that's the area with my expertise. And I think historically, say over the last 10 years, there's been a big push towards metal additive manufacturing, looking at kind of highly optimized, small scale, sort of intricate parts. And the focus has been on the design optimization. And actually, I think in the next 10 years, this sort of directed energy deposition, the large scale additive manufacturing, things like wire and arc, they will really come to the fore because they'll help us with the large scale components. So it's something like, large landing gear components or structural parts made of titanium. You're ordering this huge billet of material. You might wait many months, even over a year to receive it. And then you machine away, 90% of it. There's a lot of waste in that process, very high quality material that you're selling back as scrap to the supplier. And with additive, of course, you're building up the material you need. And even if you need to finish machine it afterwards, you're still saving a lot of waste material. So I know there's a lot of work to do in terms of certification, in terms of verifying the processes, but certainly I see that those are going to come to the fore in the future. And that fits very well with that digital manufacturing aspect as well, because we get the opportunities for new design optimization, more integrated processes as well.
Thanks very much, Helen. That's yeah, I think it's got to be the way forward, hasn't it? And that those very stark that piece about the amount of waste. Tasos, can you talk to us a little bit more, perhaps, about how Protolabs technology specifically can support the aerospace sector?
Mm-hmm. So, as we initially saw, Protolabs offers the major manufacturing processes and which are directly linked to the aerospace sector. And of course, if we had to focus on or give the next step of what we discuss about process optimization, about design optimization, and we can focus easily on additive manufacturing. So this is something that we can work on more, because we offer a variety of materials. Of course, the importance of accreditation and certification of the processes and the materials as well is key here for this industry. And the good thing is, the positive thing is that Protolabs has achieved the JOSCAR accreditation, which is the Joint Supply Chain accreditation register, which is very important for the industry, for the aerospace industry, as well as generally the defense industries. So it's really important because generally the certifications take quite a long of time to appear and to be classed, a company to be classed as certified in this sector. And it's very important to get it in order to ensure to give a better confidence and reliability to the supply chain of the main customers in the aerospace and in security and defense industries. So I would say that this is something that we managed to achieve as a company, and with the material evolution, with the demand, the higher demand on this sector, we'll be able to accommodate and work along and very close to the industry in order to achieve all these high requirements. So I would say that the certifications, I would like at this point to add the DNV certification for the oil and gas. So we see that things get moving, things get certified, and along with the material selection, with the lead time and the confidence and reliability that Protolabs can offer, we're able to offer a comprehensive solution and assistance in order to fulfill and have these challenges better.
Yeah, thanks, Tasos. We've got a couple of questions in actually off the floor, which I'm going to take in reverse order because I think one follows on from what you just said. And the first one, it said that it was mentioned there's a lot of work to do as far as certification of parts fabricated via additive manufacturing. Can we get a feel as to where we are on the certification front and how long you think it'll be before, if not so now, such fabricated parts will be approved? What's your take on how the airworthiness authorities see this? I don't know who wants to get that first. Should we stay with you for a minute, Tasos?
Yeah, I believe the certification, especially with this, for this industry, for the aerospace, is really critical. All the parts that are made, we're not talking about only the material science that is involved, is actually the process itself, how we manage to make the parts and make the parts ready for to be used directly to a variety of different areas. So the certification is definitely a key, and of course, as additive manufacturing evolves, then the actual certification will try to be a bit easier to be obtained. Of course, for aerospace, it is still there are still many processes, many steps to pass in order to achieve that. But at the end of the day, it's something that we can certainly say that it keeps moving faster. So in the very short term, I believe along with everything that we can offer, with the materials, with evolution, with the design optimization, with the process involvement, with the faster speed that parts can be manufactured, we will have the desired results with regards to this point.
Okay, thank you for that, Tasos. And Helen?
Yeah, I can add a little bit. I'm to some extent, I'm repeating what Tasos said, that it's a change of philosophy, isn't it, for the certification? So previously, an aerospace manufacturer's machining, they're buying pre-certified material and they're removing some, whereas now they're depositing material to build the parts. So the certification is around that deposition process. The machine is built on where it's built on the machine, demonstrating that. So I think there's lots of work going on. The standards have been written under a certified parts, but there's clearly more to be done. I wanted to add just perhaps a sort of practical angle as well, that I know that what the aerospace industry is doing practically is building their experience on low risk parts. So, lots of work on metal parts for, say, tooling on the ground, so that you're learning from the process without anything that's risky. And then secondary parts for flight. So the first parts, metal additive parts certified for, say, BA Systems would have been, some small brackets that, that are holding a camera that's, that there's no risk to. So it's a kind of learning process, put parts inside rather than outside. So I think it's the way, if you look back at the way composites were implemented, 50 years ago, it's probably the same. Everyone thought they would be there instantly, and it took quite a long time to build up the experience. And I think the additive world is the same. People are building experience, gaining confidence towards, that future vision of having primary structures that are manufactured that way.
Oh, that's interesting. Thank you. And yes, it will move forward. Colin, do you want to add to that, or are you okay?
I mean, the only aspect that we've not touched on yet on additive is the reclaim of the powder that's actually not used in the final part, but has been part of the process, and how we validate the powder and recover the powder that's actually not used in the part. So there's a broad piece of work that needs to be conducted in that field to say what is safe to go back into the process, and then what can be used for, say, lower risk parts.
Yeah, that's great. Thank you. I just remind everybody to put their where they work for or where they are in their questions, because then you get a shout out. And I'm glad to say we're sort of flowing in now. Thank you very much. So I'm just going to go back to Karthik, who's lecturing MechEng at Kingston. There are a few. The question really is: there are few developments in piezoelectric materials to AM, but he doesn't see ceramics. How do we see the future of ceramics and composites based additive manufacturing processes coming forward? Tasos?
Yeah, sure. Thank you, Peter. So I would say that ceramics, up to an extent, they're actually being used up to a certain extent with regards to their properties to additive manufacturing. Of course, they're not that wide spread like other materials. There are certain companies which create additive manufacturing parts, components through ceramic materials. These are quite tricky. They could be quite tricky to be manufactured. So there are quite a few parameters that we need to take into consideration. As a personal opinion, I believe that this will certainly evolve in the short term. It's not something that will not happen, but I believe that they will need to focus on certain areas and sectors of the industry, because the ceramic materials have very unique properties, and at the same time, this needs a more unique manufacturing process in order to achieve the desired result. So I believe it's something that it will definitely be a key player in the near future as well.
I think that question links neatly into another one we've had, which is, and perhaps all of you might have a view on this, as to what are the major developments which are coming down track in the next 5 years. So I'll leave it with you, Tasos, initially, and then we'll move around. I'm sure Helen has a view as well.
Yeah, with regards to the materials, the material evolution, the material science is something that it evolves rapidly. I would say that we can see that on many processes there is an open platform of materials. For example, some 3D printing manufacturers started by providing their own materials or a limited number of those, but now we can see that many very good key material players like BASF, like Evonik, have their own research and development areas where we can see a variety of different materials and different combinations of materials that haven't been considered in the past, and we see that they are currently being realized. So it's something that I believe in the next 5 years, now that especially the additive manufacturing industry start to be a bit more matured, I believe we will see a big variety of materials with different properties, mechanical, thermal, electrical, and so on. And I believe that the next 5 years, especially taking into consideration the challenges we have already discussed, there will be a really, really massive change.
Helen, do you want to give us a view?
Yeah, just a couple to add. Maybe one is in the additive manufacturing, perhaps functionally graded materials, so that you can change the material properties through your build. Imagine you could build a wing, that's got the different material properties towards the lower side to the upper side, so through a wing spar or something. I think hybrid manufacturing, we've talked a lot about additive, but I don't think those conventional processes will go away. So, hybrid forging and additive, or casting and additive, machining additive, those kind of things. And I think maybe looking further ahead, maybe sort of functionally integrated structures. So imagine that your systems are or some aspects of the systems are designed into the structure so that they can be fully embedded. I don't think we'll be there in 5 years, but in the future, I think that could be coming along.
Okay, that's great, Helen. Thank you. Colin, do you want to add on that? Or
the only thing I could add on is, if we look at additive manufacture rather than for the actual component as a process for the feeding requirements, and by feeding requirements I mean tooling. Dies have probably got a lead time, it's probably worse now, but when I was looking at die manufacture and sourcing, it was about 18 months. Additive manufacture actually gives us a great opportunity of dramatically improving that lead time, and by doing that, in that built-in 18 months, we've got the flexibility to enhance and change and mature design. So additive processes as a manufacturing process for other processes would be an area that's, I would go as far as saying, that's really low-hanging fruit now.
Yeah, no, I think that's right. Thanks, Colin. So that sort of segues, and I think into another question, which I'm going to throw at Helen first, which is from Daniel Horner at the University of Sheffield, which is, how important is the knowledge and skills in advanced design and manufacture? How important is it to engineers today those, I guess he's talking about those who are being trained compared to teaching about traditional manufacturing. I suspect you three all have a view on that one way, but how do you see that balance?
Well, I mean, it's a really good question, isn't it? For me, I think a big challenge we have is that there's, say, 80 years experience in the industry of designing for conventional processes, machining and forging, and a lot of the knowledge it's almost embedded, right? People don't even think of it that they're designing for a particular process. That is the way the design is done. So I think for younger people coming through, if we want to implement new advanced manufacturing technologies, new materials, we've got to train them. You know, we've got to bring that into our curriculum in our universities and our colleges, because they're the ones who will bring the knowledge and the enthusiasm through. I think there'll be a secondary thing as well of, you know, reskilling the existing workforce. So they both have to happen. But really, I think young people, it's a great opportunity to for them to bring knowledge that they've learned in their education and share that into the industry and bring their enthusiasm to take that forward. But you still need to learn the old stuff as well.
Well, I was about to say that begs the question of what are you going to drop, but I think that's a bit hard to put you on that.
Always.
Either the other two want to say something, or I think Helen's probably covered it well. Tasos, you obviously did. Go ahead.
Yes, thank you, Peter. So yes, I would like to just to extend a bit Helen's statement, is that the conventional manufacturing methods and the design is always a must to keep. It's the established processes, established way of thinking, or establishing approaches, if you like, on the design. So I believe it's very tricky and challenging for new engineers, because there could be a mistake if we focus only on the enthusiasm of this new technology, the additive manufacturing, because we really need to focus on just the whole process of design and the design intent, and not focus only on the easy facts that additive manufacturing can provide. Let's not forget also the software involvement as well, the design software involvement, which will certainly help producing and creating even more ideas and approaches. But it would be very important to rely and start with the established processes, because these already defined, because even on additive manufacturing, the design intent is not completely new. It is based on the established processes. So we really need to give a very good attendance there in order to avoid having only half-skilled engineers as a new generation, I would say.
Yeah. Okay.
And the only thing I would add on that is, it's not all doom and gloom. We're going to lose capability as the next generation comes through. The capability is actually going to grow, because we, like it or not, you get to a certain age, and I'm being very ageist now, talking about myself, you lose that capacity, that different way of thinking that fits with the digital environment. And there's an awful lot of benefits that we can take from the generations that are coming through education now, simply because they approach a problem in a different way. They need us, as in hand up, aged, to help scope and set the parameters of the problem that we're trying to solve. And then give them a degree of freedom to actually give the ball a kick. You know, we don't mind if, quite frankly, we don't mind if a few mistakes are made along the way, because that all becomes learning. But it needs to be in an environment where they have got the support and the knowledge of the processes of the past and the absolute manufacturing processes to understand where they could take their creations.
Okay, Colin. Yeah, thanks very much for that. To move on then, and it does fit in quite nicely, a question from Nafor Demnati of Airworthiness CVE, and it sort of fills into Rustam Satari of Asia Intelligence, which is the first question is, and I think if we can join these together, is there any work going on between YOL or additive manufacturers in harmonization of quality standards across the machinery and how the machineries and how the materials are used. And then that drops into the second point, which is approved maintenance organizations clearly see an opportunity to use 3D printing as a means of producing components, which can be immediately straight onto aircraft fit. So will approved maintenance organizations require some form of production organization approval to qualify the 3D printed components before release and fitment to an aircraft? And I suppose I would add to that, there's this, because I come from a slightly different side of the aviation world, which is what about being able to produce a part when you're deployed or en route? So the two questions is, are the industry getting together to come up with agreed standards? And what about the certification and approval for a part that's made that way once it's produced? I don't know who wants to go at that first.
I'll give the ball a kick.
Go on, Colin.
I'd say from an approval standpoint, there's something that comes with a supplier's part, i.e. the incumbent supplier's part, and that is the chief engineer's signature. So there's a raft of paperwork that individuals all around the industry have signed off on, that is the final check that part, design of part, the processes are good to go. Unless a facility has that level of authority, then those parts, certainly, I don't see them being on safety critical parts on an aircraft. Now, that kind of leads into another topic we're going to come on to, what are the opportunities for the future? And the opportunities are for the maintenance and overhaul organizations to actually combine with the component manufacturers and the systems manufacturers, the aircraft manufacturers, in a far closer way than they've done before.
Okay, thank you. Tasos?
Yes, yeah, I would point out here that it's during these years, during the involvement of additive manufacturing, and quite a few suppliers came up just offering different services and so on. So the quality of those parts were really not as expected. So I believe the most important thing would be with the key manufacturers, the key manufacturers to come together to be able to provide an alignment and a more balanced quality overall, but also at the same time being mindful of how this could be then after the end of the life, after the end of the cycle of a product, just to be able to use this material for better sustainability. So I think it's both the quality stage that needs to be approved and aligned, but at the same time how this will end up after the product runs out of its life.
Okay, thank you. Helen?
Just briefly mention maybe that the international standards organizations are doing a lot of work in this area. So ASTM and ISO are both working, and they're both then collaboratively trying to approve each other's standards so they have a common standard. I've been involved in design guidelines for additive, but they're looking at all the different metal additive processes, and they're looking at so test standards, the powder reuse standards, technician training standards right across the piece. So if anyone hasn't seen them, it's a really good place to look for information. Okay,
thanks very much. We haven't talked about the environment yet, and you can't not talk about the environment. It's critical in our business, in everybody's business. Let's face it. So, what about this new way? We've heard, Helen spoke to us about reducing waste. Now, clearly, that's significant in helping the environment. If you start with less and create what you want more efficiently, that's economically good and environmentally good. But what about this whole process? are those who are at the forefront of its technology thinking about how it can help the environment, making sure it's as environmentally friendly as possible? And what do you think its environmental advantages are over old systems? I think I'm gonna go after Helen first to see what she talked about wastage before. Helen.
So, I mean, it's like more broadly, maybe, you know, the aerospace aviation industry has made big commitments with ACARE 2050 to get to net zero in Europe. So that they're very big commitments. And a lot of what you see in the media is around the operational efficiency. So, you know, the operational emissions, so different fuels or trying to save on the operational side. But I think we have to look at the airframe as well. And I'm quite interested in these ideas of circular economy. And the aviation industry have tried very hard to take some of the steps. So there are big promises on recycling. I think Airbus have promised to recycle 90% of an airframe in the future. So that's a very big promise. There's also some good businesses that are doing reuse of high value parts out of aircraft at the end of their lives. But I think the challenge we have is to really think about that whole life cycle perspective. So right from the beginning, we're designing a product, we're using some high value materials, and then towards the end of the life, we currently think recycle and end of life. But should we be planning at the beginning for a sort of more circular approach? That's what environmental people say we should be doing. Very difficult for the aviation industry to do. But I suppose to imagine how that might work, it would be kind of saying, you know, the big titanium part that's built into an aircraft, could you identify some lower value user for that at the end of the aircraft life, so that it kind of gets automatically handed into the supply chain for, I don't know, bicycle manufacturer or, you know, something in oil and gas, you know, where the safety hazards are lower. I think they're difficult decisions, they're difficult ideas to think about, but aviation, I don't think, can avoid them. And perhaps just adding one more aspect to that. So thinking about, lost my thread. Where did I get to? So thinking about the whole life cycle, and then perhaps how to link to the way other people are working. So just looking more widely across the piece, you know, that circular economy. It's easy to say it. The life cycle is very long, so it's easy to kind of forget what will happen at the end of life. Perhaps my thought will come back to me if the others talk.
No, okay, we'll move on. Thanks very much, Helen. It's interesting you talk about turning things into bicycles. I was very struck in your statement before about integrated, being able to use this type of technology for integrated manufacturing. When you look at a modern electric bicycle, there may be some lessons we could learn there from how to integrate into the whole structure, the component parts, because they do seem to do that pretty well. I'll move to Colin.
Yeah, if you look at the material management, I think Helen covered it perfectly. There is the design study or the design education, should call it that, and the engineering education has to include a level of obviously design, but design for manufacture, design for operation, design for maintenance, and design for whole life. That's a big ask when traditionally businesses tend to sell a product once, have a unit sale, and then what happens after that is someone else's problem. Legislation is likely to come back at us saying, as we've seen in the auto industry, and same will come for aerospace, you shall take the responsibility for this airframe through its life and its disposal. So, you know, if we need an incentive to actually get on and do something before it gets mandated, I think that's it.
That's an interesting point, Colin. So I mentioned before, I come from a different side of the house. So we, you know, military aviation, of course, all the way from production to disposal is part of that process, and maybe there are some lessons that can be brought across.
Yeah.
Tasos, anything you want to add on this one?
Yeah, some great points here. So I would agree with Colin and Helen about with regards to the material reusability, because we do a lot of really nice things with lightweight constructions, smart designs, great use of material, the least possible waste. However, it has to be also predicted how this and of course the material that currently used, they have a very high reusability. However, and at the end of life, for example, when we reject some materials to be additive manufactured, for example, some parts to be additive manufactured, these materials will not be will not give the properties that promised through the process. However, this doesn't mean that they are not good for other use, and we certainly have to keep this on material usability on the loop. Also, really good point of Helen's about the circular economy. So this has to be done now, and with the key suppliers, the key manufacturers. We really need to make sure that this is predicted before even starting thinking of designing, I think. So yeah, great points, and I believe that that's great. The next go-to.
Yeah, thanks, Tasos. That's great. Right, we've got 90 seconds, everybody. So I'm not going to let you sum up, but I'm going to ask you a question. You've got about 12 seconds each, and that is, what next in aerospace? What's the one great next advancement in aerospace that you think is coming? And I'll just go around the order on my screen. Tasos.
Yeah, I believe the key area here is that it will be a very good design transition in combination with the new manufacturing processes that are offered, and of course a better and more sustainable product life cycle.
Okay, thanks, Tasos. Colin?
I'd go propulsion.
Okay, that'll do. Fantastic. We're 45 seconds to go. And for those of you who wonder where Helen's gone, they've got a fire alarm and she's left, which I think is one great excuse, isn't it, to get out of the last few seconds. So look, we have 30 seconds to run. So what I want to do is say, what an interesting discussion. Additive manufacturing has got to be the future. We're going to have to train our engineers, of course we have, and we've got to solve quickly the certification issues, which will be new, particularly if a component is going to be created off-site, if you like, in a way it hasn't been before. So my thanks go to Helen, go to Tasos and Colin for being here with us, and to all of you, which I think the numbers were certainly up in the 80s and 90s at one point, if not more, for being here. From the Society, Emma and Kaylee, thanks very much for organising it. And thank you for those who put in questions and everybody else. Thank you very much. Bye-bye.
Thank you.